I want to take a few moments to talk about this equation here. And basically I want to build up to how did we get to this equation, starting with the basic definition for variance. So the variance of x, by definition, what is variance? It is the expected difference between x and the mean of x. Now the mean of x is usually written, it can be written as mu. You might see it written sometimes as the Greek letter mu, but that's the same thing as the expected value of x. Okay, so it's the difference between x and the expected value of x squared. Okay, so we do that square and then we take the expected value. So I put these brackets to make sure you're taking that square first and then you're taking the expected value. Okay, so this is by definition what the variance of x is. And so how do you get from this to this? That's what I want to spend time talking about right now. All right. So let's go ahead, and what we'll do is let's first write this. Instead of writing it as a square, let's write it as the product of two differences. Okay. So I haven't done anything here. All I've done is, instead of writing it as square, I'm writing it as a product. Okay, and then I have that expected value of this product. Okay, so I have the expected value, and now I'm going to go ahead and FOIL. So remember, FOIL is first, inner, outer, last. Okay, so I'll have x squared minus x times the expected value of x minus x times the expected value of x plus, right, because negative make a plus, expected value of x squared. Okay, I can simplify this a little bit. I have, these are like terms here, so there's two of them, so minus 2x expected value of x. Actually, I'm going to write that a little bit differently. I'm going to go ahead and write this as expected value of x times x. So it's the same thing, I just kind of reverse that multiplication. Okay. All right, so now I'm going to take the expected value of each piece of this sum. So I have the expected value of x squared minus the expected value of 2 expected value of x plus the expected value of the expected value of x squared. Okay. So now we need to remember something about expected values. Okay. So when you take the expected value, that is the mean. That is the mean of x, right? And that is no longer it's like a constant. It's no longer a random number. So remember, if I have, say, the letter A is a constant and y is a random variable, this using properties of expected value, this equals A times the expected value of y. So basically you can pull a constant out of an expected value, pull it out front. And you only need to keep what the random variable is. Okay. So what's my constant here? Here my constant is 2 times the expected value of x. So I can pull that out. So I'll have minus 2 expected value of x. All right, and then my random piece, I still have this x back here. So this is the expected value of x. Okay? So the constant comes out, and I still have the expected value of x. Now this last piece here is the expected value of x squared. That is a constant. Okay, there's nothing random there. So when I take the expected value of it, okay, the expected value of a constant is just itself. It's just a constant. So this is plus the expected value of x squared. Okay, so that's the constant. All right, so now I just need to simplify this a little bit further. Almost there. I have 2. Now there's 2 of them, so that is the expected value of x squared. And then I still have the expected value of x squared at the back. All right, so I notice these are like terms. They both have expected value of x. It's minus 2 plus 1, so that leaves minus 1. So I have the expected value of x squared minus 1 times the expected value of x squared. Okay. So now I've shown, all right, basically using some algebra, that you can go from this equation, which is the definition for variance of x, to get to this equation here. And it's, this equation here is a lot of times it's easier to do additional calculations with. So a lot of times you will see people go ahead and start with the variance of x equals this. And this is the work for how they got there. Okay.